Hello, ladies and gentlemen, Minecraft fans. In my last video, I was showing off some Redpower experiments, if you want. In this video, I'm going to show you how to make a very basic fourth program using Redpower. So you, in effect, could replace redstone logic in-game entirely. But before we do that, I have one thing to show you. I'm quite confident that most of you already know my old refinery, and I'm especially talking about the one where I had a dock and a large oil tanker I was pumping oil through. And if we check out this map here, I'm working on a new one for current version of Minecraft, and I'm calling it Vaupell's Vomitorium. Yeah, you should look that up. And as you can see, I've been working on a dock area and some slow loading chunks, and the ship is in the works, so we're getting there. And we'll see how this will work, and my plan is of course to use a combination of Buildcraft and Redpower too, and frames. That's very important. Frames and computers. Alright, let's get to what's important for today. In my old world, awesomeness. Yeah, in case you missed it, I can't really remember if I showed it, but meat. I've been working on a meat production facility using frames. And as you can see, we're burning pigs and chicken. Because they are so damn tasty. Cooked chicken. Sometimes I accidentally burn off the, the meat. Well, shit happens. This is a prototype. I imagine if I did a proper size it would be a bit more successful. But at least it works. Okay, computers. Today we're going to look at computers and burning wolves. Anyway, look at how to make a computer work. So basically, like this one, when I go up to the screen, I just enter and I type farm and everything is running, as you can see. And actually you could make it a button function, so you could add a block with redstone and a button on here. And this will also be able to activate the computer. But we will save that for later. Let's get some items set up. Since we don't have any plans of what we're going to build, we're first going to just set up a computer. We need a I/O expander, we need a monitor, we need a CPU and disk drive. And we don't need the expansions at the moment. And well, let's just set up shop right here. I/O expander and CPU. I always like to just have a little space. That basically just shows you don't have to have a direct connection between them. Well, you do need a direct connection, but you don't need to place them right next to each other. But you can do this. And in fact you could have several of these. 2, 3, 4. Let me show you. I'll have this over here on the dam. I'm using 2, 1 and 2. This one is to control mechanics, and this one is to control the lighting. And it's basically just the same cable, but the difference is they have this one has a bus ID of 3 and this one has a bus ID of 4. And you just write it into the program with the address. So as long as you can come up with new bus IDs, you could add more expanders. Anyway, we need a operating system. We got that there, and we also need a blank floppy. We got that there. Maybe two. I like to keep a backup in case something happens, and a chest to store everything in. A blank in there. And I'm putting the operating system in the drive. Go. And we're just going to start the computer by clicking start. And yeah, as you can see, it writes mine OS version 1.0 initialized, which means it has loaded the disk into the memory. Remove the disk, and I'm going to put in my own disk. And the reason I'm using my own disk is because that's where I also save the operating system and everything new I add. So the first thing I'm going to do is type save, quotation mark, and the name of the disk. Name of the disk, quotation mark. Press enter, and it should have saved everything in the computer right now onto the disk. Let's see. Name of the disk. Don't mind the number, that's just not enough items showing the item ID. But as you can see, it's called name of the disk. Put it back in because we're going to use it, and we're just going to check the ID. There we go. That's because if I want to copy this disk to another computer, I would find this file in my world, in my save folder in the world map. There is a file called F450E9922D20-1F4C. This file I could just copy over. That's awesome. Okay, basic functions. First of all, to get output from this box here, you need a multicolored cable. Let's see, what do we call them? We call them bundled cable, and you can use any of these. And we're just going to use the light blue today. There we go. And out of this cable you can pull 16 colors, as you already should know. And the colors are in order, like they're shown here. So white, orange, magenta, light blue, yellow, lime, pink. And they are binary coded, which means this is number 1, this is number 2, this is number 4, this is number 8, this is number 16, 32, 64, and so on. So if I use white wire, let's use a lamp so we can see. They were right there, and white would be very fitting. Let's make a few of these. And then we want orange, magenta, blue, and yellow. And the same with the wires or cable. Orange, magenta, blue, and yellow. And it's getting darker there. There we go. So we want to activate a redstone signal, and as you can remember, I said the binary code is 1, 2, 4, 8, 16. And we could test now if it is true. Let's see if I can stand so we can see the lamps. There we go. You can see them over here. And the way it works is, first I select my binary code, and we want the white lamp to light up, so we press 1, and IO_X means we want the signal 1 to go to the IO expander. And as you can see over here, it's now lit up. Let's try 2. And as you notice, it will turn it off. Because it's binary, you only have one activated at a time. If you want to activate multiple at a time, you need to add them together. Like that. And you can see we got both white and orange. If you want to turn the signal off, you do this. 0 IO_X. You could also use a command called 1EOX set, and don't use the exclamation mark. Oh my god. There we go. It's set for 1, basically it does the same. I don't use it, it's nice. There you can see. You can have multiple turned on and off by using that command. There we go. That's the basics. Okay, there's one more thing you need to know. So you want to light, well, let's just say the first 3 up. Like this one for a second or 2, then turn it off, then this one, turn it off, then this one, turn it off. You can write a small program, and to write a program you start with a semicolon like that, and you write the program's name, and let's call this one flash, and it says compile. The first thing we wanted to do was to lit up the white one. There we go. It doesn't actually do anything right now, as you can see, because we're just pre-programming it into the program called Flash. And right now we have told Flash that first thing we want to do is have the white one lit up. Then we need a break or a pause. That's probably more correct. Use a pause before we're turning it off. So let's say 20 ticks. That's about 1 second in Redpower terms. And you do that. Nothing else. Don't write ticks 20. That will just make your program freeze up. Not Minecraft, just the computer inside Minecraft. 20 ticks, that's 1 second. But then you want to turn it off. So we write 0 IO_X. That means we turn the white off. And very short, half a second. Then we turn the orange on. Okay. And again, we wait 1 second. Turn it off, and then we want to turn the magenta on. And as you can see, you can easily go out of the program and go back in and continue, so don't worry about that. For IO_X, no, remember the pause, 10 ticks for IO_X1, and 1 second wait. So it's up, turn it off, and make sure the system can keep up, and there we go. Now we have a program called Flash. I'm going to type Flash and press enter, and as soon as I do, I'm going to press escape so we can see if it works. There we go, white, orange, magenta. And if you notice down here on this box, it's also showing what's going on. You can see first one, the second one, and the third one. That's very nice. Elerom has been so nice to put in a times command, but basically that's a loop or if you're a basic programmer, you know for and next. So if I want to run this program 5 times, I could just run 5 times flash. That means it will run from this point to this point 5 times. Let's try it. There we go, we're running on the first, second, doesn't matter. Now we can see it works. So we're running the same program 5 times. And as you can see, that actually replaces almost most of the common used redstone logics, because you can time things, time signals, and you can control how long before the next signal activates, so you don't have to fiddle around with right clicking some repeater or making sure the delay is correct. This is much easier. And let me show you on the tree farm again. As you can see, 2 times farm. That means it will now farm 2 trees. Okay, now let's look into subcommands or additional wording. They are called words, these small programs in Redpower 2. Let's see. Let's build a machine of sorts. On page 3, there we go. We need some like that, like that. Now we have something that can move back and forth, as you can see. And I'm, as soon as I'm building, just going to add a limit. There we go. That means it will only go there this much, and the same on the other side. So we're not going to run it off the tracks. And there we go. Now we want to hook up these 2 motors, and we still got everything connected to the computer. And something I like to do is when I hook up engines like this, I try to remember when I say something like back and forth, I say back first. So my first command is back, and when I stand here, forward for me right now is probably to the right. Of course it should normally be that way out to the water, but right now it's to the right. So back is this, and forth is the launch. It's not necessary, it's just something I need to do to be able to figure out what I'm doing when I code the damn shit. Okay, let's try this. And we could use the flash command now, but it wouldn't really work too well. We could try. No. And the reason it won't work is because there's no power. That's a idiot's mistake. Yep, that's me. These engines need electricity, so let's just add some. And we need, oh, there we go. And a battery. Battery. There we go. 1 is enough. Soon we should be able to see the blue lights lit up, and then it should work. And it's charging up slowly. Daylight, please. And yes, here we go. Blue lights is on. Machinery should be working. Let's type flash, and you can see it moved one and back. And right now it should be turning the next button. But we have no use for flash anymore, so let's erase that. And when you erase a program, you must remember to use the semicolon at the end. If you don't, if you just leave it like this, it will erase all the programs you have made yourself. This, it will only erase flash. There we go. And we can check by typing words. Of course, this time I didn't have any programs on this disk, but in case I had several. Anyway, I'm now going to write a command to make this thing move forth or forward. So let's try this. Colon first, type forward. And since my forward command is on the white wire, I'm going to turn the white on. And now it's important that you leave at least a second for the mechanics to run. Well, depending on if you're single player or multiplayer. Single player, you could probably leave it at 0.7 seconds, maybe 0.8, but I always prefer 0.1. It will leave a pause, but hey, shit happens. And 20 ticks is 1 second, so let's just go 18 ticks for fun. That's 0.9 seconds. Okay, and then you want to turn it off because you want a redstone signal, a pulse, not a constant signal, because a constant signal doesn't work. So we turn the signal off with the 0. And when we turn something off, you only need 10 ticks. Well, you could probably settle with 5, because that's just to let the signal get through the wire, depending on how long there is and how much lag you have. Then we want to turn it on again, the same direction. We want to wait until the motor actually has completed the move and then turn it off. And okay. Oh my god, you saw that? You saw that? That's a rookie mistake. There was no space between the exclamation mark and the colon, semicolon. Let's try it again. Forward, move one forward, wait, turn signal off, wait 5, program complete. This will move this boom one part forward. Let's try it. Forward. It works. Now we need another program called backward. Or just back. And since we have the back motor connected to orange, which is 2, we just turn 2 on, 18 ticks, turn it back off, 5 ticks, waiting for the wire, end program, back, and it works. Now we can write a program that uses these two commands. We can make a program called test back for. You could call it anything. I'm just calling it this. And we want to run the program forward. That means it will now move everything I wrote in here once. And I want to move it again. Now I'm moving it twice, and back, end program. Test back 4, and it should move 3 times each way. Yes, it is working. We are happy, clearly. Now that everything is working, I want to save my disk. And this time I'm going to call the disk, save, backup disk. So all my programs are stored on the disk, and I can now put it in the chest, and I can take a blank floppy and put in here and save main disk. The reason I do this is because right now I'm messing around with the configuration of Minecraft, and sometimes when you re-enter, all of these items are turned into something completely different, because you're changing the game IDs. And if your disk is in there and you change it, your data is lost. But if you have it in a chest like this, it is not lost. Just a tip or pointer. So basically, as you can see, you can write programs that do many things, and you can use the words of the programs in combination to write something else. No, that's a bad color. That's a very bad color. Let's try magenta. Where are the lights? I want to add a small light now. Sure, an orange lamp. And this doesn't work, so we need a ordinary wire. Red. There we go. Now I want to add a command that makes this one flash or blink just once. So let's make a new command called blank. No, there we go. Error, please. Whatever. Blink is what I wanted. Blink. And as you noticed, I used magenta wire, and magenta is the color. Let's see over here. 1, 2, 4. So that's number 4. 4 IOX. And since it's light, it doesn't need that much time. Turn it back off, else it's just on all the time. You could leave it on if you want to create something like a lamp. That could work. But right now it turns on and off. Let's try it. Blink. There we go. 10 times blink. And you can see it's just constantly on because the signal is going too fast. Did you notice I didn't use any ticks after the 0, and 5 ticks are too little, so when you do it like this, it's just constantly on. But instead of rewriting the program, we could create something you would call blink 2, and inside blink 2 we use the blink, but then we use a 10 tick end program, which means between each blink it will stop blink 2. If you just write blink 2, nothing new will happen, but if you write 5 times blink 2, there you go, you got a flashing light. Very nice. So now we got a moving beam and we got flashing lights. You could also combine these with ordinary redstone logics, and I actually got one to show you right here. This one, the toggle switch I use for lighting and the gate control. So when the computer sends a signal to this toggle, it's easy to control what I'm doing right now, which means if I'm trying to open the gate and they're already open, nothing will happen. If I'm trying to turn on the light and it's already on, nothing will happen. That's how the toggle switch works. So if I go here and type light, let's see, light is already on. Light is still already on. How about that? Dark. And it's off. That's what the toggle switch does. Except for the lighting, I have it inside the computer. And this one is actually for the gates. And the reason I have it for the gates is because I have added these two. These two are not necessary when you program. You could just write, let's see how much is 2 seconds, that's 40 ticks, so you could just have a signal turned on and off each 40 tick, and that would have the same effect. And you could, but as you can hear, I have made this system multiple compliant, so it both works with a button. Well, there we go. If you look over there, you should see it coming out of the ground. Yeah, and water. And that's exactly the same as if I wrote gate. You can also hear it. Daylight. So that's about it. There might be one more. Well, the biggest challenge of all these builds is making it possible for wire to cross over moving parts. That's basically what I have here. All of this is moving. This is not moving. So whenever this wire is moving down, it's just reconnecting. Let's see if it works. Harvest. But right now it's moving this way. And it's only using the redstone pipes. But it's basically the same. And now it's using the fourth command or forward. And notice this cable bunch when it's moving down. It's going to now. There we go. That's how it works. One more thing worth knowing is if you have well, let's see if we can get this around some multiple IOX boxes. Let's try this. Where is it? Like so. Let's just save everything. And this. And let's see. This one has a bus ID of 3. This one has a bus ID of 3. We need to fix that. There we go. Bus ID of 4. So 3 and 4. Now we want to stop the computer. Stop. Reset. Start. There we go. Now we have 2 boxes. Let's try and turn on the white one in our main box. You can see, and this one moves. We could use a different color for the other box. Let's try. Almost the same. Funny. And let's use the same color wire. And a light of sorts. There we go. Now they're both connected to the same computer, but only one of them turned on. So, to make this work, we need to tell the computer we want to access this IO expander. And we do that by remembering the bus name. This one was 3, this one was 4. So we're going to enter the computer and type 4 EOXADDR. And I can't remember if I needed the exclamation mark. But that's basically how you access the next box. And we're going to send a signal, and it failed miserably. That's because I'm missing something. Let's check the words list. IOXADDR. No, it's incorrect. Let's try and make a small program. Let's turn this one off. So basically we're going to try again. We're going to type 4 IOX ADDR exclamation mark 1 IOX, and it worked. Fucking yes. Now if we want to access this one again, we need to make sure we type 3 IOX ADR exclamation mark and 1 IOX1. There we go. Both are on now. This means we could write a program using both expanders. Let's try this. Test both. First thing we want to do is we want to move our boom over here back 2 times. Back. Since we already have pre-programmed back a bit earlier today, and we can see it in the list as well right here. We want to move it 1 forward. Then we want to connect with the second IOX expander like this, and we want to turn the light on. But now we should remember to add some wait time. Now we want to turn it off. Then we want to connect to the first one. And we want to move 1 more back. And why the hell not? Blink. What did we call it? Luckily we have a list here. We call it blink 2. And that's our program. Let's turn everything off before we start it. 4 IOX ADDR exclamation mark 0 IOX. Turn the rain off, daylight. 3 IOX ADDR. There we go. Everything is off, and we're going to test our program. We call it test both. So it starts off by moving, and notice the lights down there. It's using both. Everything is working. Let's do 3 times test both. And we're now running into problem with our boom over there, as you can see. But it will still try to use it. That's basically how you program the most basic features of Redpower. There is one more kind of important function, and it's one I use a lot, and that is what most people know as a do loop. Do loop, just like that. And the way it works is when you have a command, well, now we have this command up here called forward. I want to make a new command called reset, and basically I want to make this boom over here move back to its original position, which is how many? 1, 2, 3, 4, 5 in that direction there. So I want to move it 5 forward, 0, ignore that, do, and what function to do 5 times. I want to do forward 5 times and loop. And then that's end of the program, and you could add multiple of these. That's just how the do loop works. And let's run it. Reset. And let's type the correct lettering. 1, 2, 3, 4, 5. There you go. Basics of Redpower 2 programming. And of course there are a lot of more advanced functions. As you can see, all of the predefined functions are listed here. And the great thing with this is you could just create your own functions by combining these. And since you can make a word and use the word just like we did up here, you can just put the word inside another, well, function or word and make it even more. So you're creating loops within loops within loops. That's basically how it works, and that's how you create nice machinery, like a pig burning machine, or tree farming, or wheat farming, or whatever. Or maybe even a refinery with some sensors from, oh, I don't know, let's say Buildcraft 3. You have sensors on tanks and gases and everything. Thanks for watching, guys. Comment, rate, subscribe, and remember, Minecraft is just entertainment. See you!